So today's topic is temporary works design briefs. Temporary works in general can be fraught with risk if it isn't planned properly. Here's some standout examples of large-scale temporary works failures in the last 20 years or so. So on the top left-hand corner there, we've got the Florida bridge collapse. It's not in the UK, it's in America. But it's well worth tracking down the OSHA report. OSHA are, from my understanding, are the equivalent to the HSE in America. And the report that they produced on the back of the failure is quite worrying reading. There's not only design errors, but the lack of action on site could carry on until the bridge collapsed. Gerrard's Cross, the next one along on the top right, is 2005 precast segmental arch collapsed during construction, being backfilled each side of the arch when it collapsed. Luckily, nobody's killed, but the rail was open. Nichols Highway, that is in Singapore, 2004, and that's a large-scale tunneling collapse. Papers are available online, which detail the reasons and the engineering behind the collapse. One key finding that there wasn't an independent check. That was one of them. But UK version, I suppose, would be Heathrow Airport, the tunnelling disaster following the new Australian tunnelling method. There's a lot of information out on the internet about both of those, so it's worth a look. And then finally, the bottom right-hand corner, we've got Didcot Power Station. That was 2016, pre-weakening of a large steel structure prematurely collapsed. That was real kind of eye-opener to the demolition industry for sure, and investigations still ongoing on that one. We have got a webinar that covers the temporary works flowchart, and that flowchart review, including some of those case studies there, and that covers the procedural control of temporary works more generally, as opposed to today's session, which is going to be a more focused review of the design briefs. So make sure you check that one out, which is on our YouTube channel. So we've got these disasters. Yes, temporary works can be fraught with risk if it isn't planned properly. But how long has this been happening for? Well, it's quite a while. Really, it just goes hand in hand with construction. The required control is becoming more and more important now, though, as we start to build things, or we are building things which are much more complex in more complex environments. If we go back to 1909, Newport Dock, we've got a photo here of the aftermath of what was left after the collapse of a large excavation support system. It's a large earthworks failure. Earthworks failures often are very expensive to remediate and cause a big mess. On this one is 38 fatalities, but we don't actually know whether that is the correct figure because they didn't have the same site registers that we do today. This case is the earliest temporary works failure that was referenced as such, and in fact it was discussed in Parliament as well. Fast forward a little bit, it's 1972, I think, Loddon Viaduct, it's a bridge just outside Reading. It's the construction of one highway in each direction, and during the construction of one of the bridges, the false work failed, leading to large-scale collapse. Only 3 were killed in this incident, which is quite impressive. Or impressive, not really the right word, but it's astounding, I think, probably more appropriate word, because there was operatives on top of the structure as it failed. And that's more by luck, that the fact that we had as few fatalities as you'd expect, because it happened on a lunch break and they were staggering the breaks as well. So there was a reduced number of people on site. There was also references to once some of the guys on the span felt a slump in the deck as the thing was about to go, they were able to jump across to the other side of the bridge that had just been constructed as well, which is also gobsmacking. Yeah, large-scale collapse, 3 fatalities. And so what we found is that during the 50s, 60s, and 70s, the post-Second World War infrastructure boom, there was some large-scale infrastructure being built and large-scale collapses that were the results of poorly planned temporary works. And that was a fact. These failures led to the industry leaders sitting up and thinking, We need to do something about this because it's certainly something that we can avoid, surely, for the future going forward. It led to the Sir Stephen Bragg and the Bragg report. So that's a committee that put together an investigation and put a report together to review the failings that the construction industry had as it was, and identify some recommendations on how we can improve. And most of these recommendations that came out in 1975 were incorporated into the British Standard of Temporary Works, BS 5975, as we have it today. And some of the key ones I've listed here. So we've got a number of them associated with lateral stability, making sure that we have a structure, if we're supporting something, that it is suitable for some form of lateral load. It doesn't just all fall down like a pack of cards when we accidentally hit it with an excavator bucket, for example. So we've got horizontal loads looking at lateral stability, lacing and bracing of props to provide that lateral stability overall on the propping system. The use of proprietary equipment and their instructions of use. Instructions of use for proprietary gear is really good now with 3D sequencing of how to put things together and how to use things properly provided by the manufacturers. The management and procedural control of temporary works is a really key one. And in fact, 5975, there's a large portion of that British standard, which is the British Standard for Temporary Works and Procedural Control, and also the permissible stress design of false work. A large portion of that document is dedicated to how temporary work should be managed on site, and also what procedures should be in place to help reduce errors, and so we have the best chance of spotting them as well before they lead to potential failure. That's the key really for that procedural control. It's minimizing the chance of an error being made in the first instance during the design phase, and then during the construction phase, maximizing the chance of spotting an error. Then the last one on that list there, which I'm going to pick out, is the importance of design briefs. This is especially prevalent now that temporary works design is commonly carried out by engineers that are not based on site, and therefore the brief should identify interfaces that may not be clear to somebody who isn't familiar with the site, who may still be designing the temporary works. And it's worth noting as well, while I'm on this slide, that the time of the publication of the Bragg report, that the construction industry was quite a different place to what it is now. So we've got HASWA, Health and Safety Work Act, that was 1974, and this is 1975. So health and safety legislation was just really beginning to bring improvements to sites, and there was also little subcontracting of construction work to outside of a construction organisation, with most trades being carried out by the main contractors' operatives. Whereas now, a lot of the work is subbed out. So we've got a lot of different parties carrying out work on that particular site, which is why the CDM regulations have really been key to playing a role in ensuring that duty holders who are a part of the construction team, including the design team for that build, are competent, and those appointed to plan, manage and monitor the work, or in this case, plan, manage and monitor the temporary works, are suitable for the job and competent to do so. The legacy of the Bragg report still kind of ripples through the industry, and is still relevant even with the turn from British standards to Eurocode design. This paper here that I've popped on there, that's worth a read. It's an ICE publication and can be found with a quick Google if you're looking for more information on the Bragg report. But essentially, we can boil the importance of design briefs down to a few points. So we know that temporary works can be potentially dangerous if not planned or managed properly. We also know that a large part of the planning and managing temporary works is getting the right solution. Getting the right solution goes hand in hand with the design, and therefore getting the design right is absolutely key. So getting the design brief correct to inform that design and arrive at the best solution at the end is therefore really critical to the prevention of a potentially dangerous situation arriving on site. And this design brief is a keystone really to the design process, and getting it right in the first instance, and getting it right is important. The design brief, where it sits in that procedural control, it comes before the design and it is started, and is usually written by the temporary works coordinator once a construction strategy has been agreed, because it's only at that point when you'll know how you're going to build something, and therefore what kind of temporary work solutions will be required. We've got an online temporary works flowchart, which takes you through the whole process of temporary works from the project's inception through to completion, and Christian has put that link in the chat. It will take you to a login details page, and it's totally free. You put in your email address and make a little account, and then you can click and choose the most appropriate option, whether you're a principal contractor or a managing contractor or a subby, and then it'll take you to an interactive flowchart which references BS 5975 directly. And then we've also put little interactive buttons which tether the particular clauses to the relevant stages of the process. So you can see here that the design briefs, they can be written once the temporary works register has been filled in, or at least started. And then the design briefs can come before the design team are selected as well. So they can all be sat there ready to rock and roll before your design team is selected, and issued to prospective engineers for quotes, and then back and be ready and waiting in draft form until all the information is available to enable the design to start. Okay, so we know the history behind the design brief and designing temporary works. We know where it sits within a project now. Let's take a look at some of the content that we would expect to have in a design brief itself. So the design brief, it should give the designer all the relevant information to complete the design. It may be the obvious stuff, what needs to be designed, the category of check required, etc. I've put in a couple of extracts from BS 5975 here. So it needs to provide the intent and the information for the design to be carried out, first and foremost. And it doesn't necessarily need to be a formal document for every single task, but it should have the information to allow the design to be completed and checked. It is good, in my opinion, to have a written trail of what was asked for when, and it can be used as a bit of a tool to bash your design engineer on the head if you've asked for something formally and then you get the design through for review and you think, oh, well, they haven't included this or this part of the design. It's very difficult to go back when it's just through verbal. If you've got a written design brief, then it's very simple to go back with that written proof. Some food for thought there. So a few sections that I'm going to cover next will be the kind of appropriate things to include in a design brief, and I'm going to use our Andon design brief template, which is downloadable from our website. And again, Chris has put the link to that in the chat. But if you go to our website, andon.co.uk, then you click on resources and it's under the resources there. So what should be included? The design check category should be included, and the implementation risk class should also be included. The different design check categories are listed in table 2 here, which is straight from BS 597. Essentially a scale of how independent you'd like the person checking a design to be. If it's a low risk design, then not necessary to have a drawn out checking process. So a basic check from someone who's within the design team is more than acceptable. However, if it's high risk and it's a bespoke scheme with innovative design, including departures from industry accepted standards, then it will be more than likely a Cat 3 check would be required, which is another organization carrying out their own independent check without looking at the calculations that the designer put together to inform the design. Implementation risk as well. So that relates to the execution risk, i.e. how it's installed and removed and the competency of the contractor building it and the workmanship, etc. So it's the execution risk of the temporary works as well as the consequence of failure. And the consequence of failure is what happens if it goes wrong. If you stand back and think, well, if this thing was to fail, then what would happen? Would it be a domino effect into a large scale collapse, or is it just something that's going to fall over in the middle of a green field? Well, the Harris fence has fallen over. Well, we'll just pick it back up again and, move on with our lives. This implementation risk class should be put into the design brief, and it's classed by the temporary works coordinator with input from the construction and the design team as well. So all those parties can be brought together to understand what risk there is, and therefore what risk class it sits in. The difference here is that it's not necessarily governed by the design. So with the implementation risk class, a hoarding, for example, or an excavation support scheme in a field, thus carrying low consequence of failure, compared to if that same design, exactly the same design, failed in a busy shopping centre or adjacent to a railway. If it fails in that environment, then the likelihood of fatality increases, or large economic loss increases. And so the implementation risk class should really, for me, outline the company procedures to follow. It may be that there's a peer review or further permits and hold points to include. But really, for me, as a broad brush comment, is it tells you how much planning time, resource, and attention to pay to a particular scheme. If it's higher risk in the implementation risk category, then you're going to be spending more time reviewing that because it warrants it due to the consequence of failure or the who's installing it or workmanship side. So what else should be included? So here we've got the description of the temporary works required here. So try to think of this as a problem rather than trying to go straight to the solution. Tell the engineer the full story of what's required. So such as, I want to put a piece of plant on the slab during demolition project, rather than let's design some back propping for this piece of plant which we've got on the structure. Or for another example, I need to install this reinforced concrete wall, rather than can you redesign some sheet piles please, because I'm going to put them in front of an area where I'm going to build this wall. This means that the design engineer that you're employing can look at safe batter angles for that instance, or alternative solutions which may be more economical, which you've perhaps not thought of. Are there any historical archive drawings of the structure, or does site investigation, which is often called SI, need to be carried out? Do we need to specify locations for where the SI needs to be? This can all be included in the wish list. After all, you ask for what you want, or you get what you're given. Here we've got a box on preferred methods, systems, and types of equipment. So here you can describe what we would like the engineer to design, preferred methods, etc. Or if you've got any preferred kit, or you've already got a supplier on site who is already on the books, so you'd like to use their kit. Is it likely that it's going to be in there for a couple of years? If so, a fabricated steel solution may be more appropriate as opposed to hired proprietary kit. In more of the ground area, would you like to use a geogrid reinforced or chemically stabilized working platform? Or you may have loads of crushed concrete material because you've just dropped a large reinforced concrete frame. So you've got pure crush material coming out of your ears. So you might want to, even though it's going to be a deeper mat overall, you might prefer to say, well, I don't want to use geogrid or anything like that to reduce the mat thickness because we've got loads of gear on site, so we might as well use that. And on a simpler scale, if it's a post and hole, if it's a hoarding, is it post and hole, or is it Kentledge based, or what Kentledge you've got? Or you may have load of acros on site, so rather than using a one bigger prop, you could say, well, I'd rather double up acros, that kind of thing. So be resourceful of what you've got available. So then the engineer who's designing it can also be resourceful. Next is ground conditions, which is probably one of the areas where information is most lacking. We've got a crane coming on Monday, and we've got it here, see attached basic spec of the crane, like the PDF that you get online. We need a bit more information than that if they're going to get a efficient solution. So descriptive ground conditions are only so useful up to a point, and will require some confirmation or testing on site quite often, such as SBT tests or CBR tests or plate bearing tests. They can be undertaken on the formation level, and that will allow the design to be refined and much more efficient. Or it may be that there is a full SI report for that particular area. It may be that we can use historical borehole information, which is freely available online. So it's one of the solutions that we could go with if we're lacking in some areas. But the more accurate this information is, the better the overall design output's going to be. So if we take water levels, for example, I've shown some little sketches here of some typical angles of repose, which are only indicative, but just proving the difference of the angle of repose in three amounts of moisture content for a particular sand. So if we've got a fully saturated sand, i.e. underwater, then the angle of repose is relatively shallow. And similarly, if we go totally opposite end of the scale, we've got totally dry sand in the Sahara Desert or something, then the angle of repose is also quite shallow. But if we put a little bit of water in there, like we like to use for our sandcastles, then we can pretty much get a vertical angle of repose. Maybe short term, yes, but still it's a pretty much a vertical face. So that shows that water can have quite a large influence on the ground capacity. And so if we have a good understanding of what's there, then we can do a lot with that information. Something else that should be included. So we've got design limitations, whether they're site imposed or they may well be contract imposed. When we think of design limitations, the main one here really is the third party interfaces. Who is it on our boundary that we're going to affect during the proposed works? And what kind of hoops do we need to jump through to make sure that everybody's a happy bunny? Are the works going to be interacting with Network Rail? Do we need to put together a BAPO, which is a basic asset protection agreement with Network Rail? Will we need a CEM role or a CRE role and complete Form Cs, etc.? We need to know that up front so we can then allow for that as part of the design. Are we going to be altering a public highway? And in which case, do we need to complete a document which is known as an AIP, or approval in principle? And then do we need to assist in getting those approvals as well? There may well be some specific limitations that need to be considered, which are also bespoke to that particular job. Each project is its own specific site, so it may well that there's some quirky things apart from that's a part of that job which we need to review as part of the design, and that should find its way into the design brief. There may well be particular loading conditions or considerations that we need to be thinking about. So is there going to be a combination of temporary works loadings and permanent works loadings? Can the loads from the permanent works be confirmed and communicated through the design, or is it necessary to include some form of workshop at the front end before the design brief is finalized, or like a coordination meeting to inform the design brief so that everything or all the information that is required can find itself onto that brief? So a typical example for that on the structure side would be a tower crane foundation. So if we have a piled tower crane foundation that's ultimately going to be incorporated into the permanent works, then it's more than likely going to have some walls or columns on that base as well. And the loading requirements and combinations for that whole design life of the tower crane, so tower crane erected without any columns on it, and then tower crane erected with columns on it and with columns loaded, live loads on different ones. It's quite a complex process. We need to know that in the design brief so that the design engineer can facilitate those loadings. On the ground engineering side, I suppose it'd be more like if you've got a post and hole hoarding, keep it simple, around the perimeter of the site, but you've also got some ground beams that you need to install later on in the project. And so these ground beams are going to be just behind where we're going to put the hoarding. So if we know that at the first instance, then we can design a solution that's going to fit the bill for the whole project. So we're not mucking about later on in the project when we're worrying about undermining that hoarding. We find that optimum solution, so it's all done in one go. Access limitations. So is it possible to install the temporary works in blue sky conditions, for example, or if we've got things in the way? Can they come back out the same way as they're installed, or will the permanent works be constructed afterwards, which will influence the removal? Because a lot may well have happened since the last install of the temporary works. A lot may have been built around, and I can think of a couple of examples where this has happened in the past, and one of them is at Birmingham New Street railway station, where there was a large excavator demolition spec, and it was used to remove the upper retail level and lower retail level, and it was quite a large piece of kit, and it was in this structure for quite some time. When it had finished its job, it had to essentially be dismantled and taken out on little trolleys because the new structure had been built kind of around it, around the periphery. Another example was at for a large tower development in central Manchester, and the tower crane was a key in moving a lot of the equipment around. But once the tower crane had been removed, we need to think about what was going to remove that tower crane. So we had a spider crane on the roof to remove the tower crane. But once the tower crane had been removed, then we had a spider crane on the roof, which couldn't necessarily be brought down from the street level because we'd built a lot of structure in the way onto quite a narrow street. So that spider crane had to be kind of dismantled into parts and taken down the goods hoist. Those limitations in access and egress are quite important and may well be the trickiest part of the job. So it's important to include those and don't get caught out with those access and egress limitations. Similar to site investigation, it's worth understanding the existing services that will be potentially affected during the proposed operations. If we've got service drawings available, then that's smashing. Have they been confirmed as being accurate on site, or do we need to do some investigation to see if it is in fact as accurate as what the plans may well suggest? If it's critical where those locations are, then they should definitely be confirmed as in accordance with the plans, so through ground penetrating radar or something similar. Do manhole covers need to be protected, or chambers left accessible, or can they be covered up during the works? And anything else really, historical drawings or as-builts for demolition projects, these are quite helpful, showing where existing services are. If they're underground or overhead, we need to know about them in the design, so then we can design accordingly. So in summary, there are some pretty key requirements to consider, which I've listed here. A lot of them I've covered in the previous slides, but a key one, I think, as I'll pick up now, is the timings of the removal of the temporary works. Something that is good, or something that needs to be good for a single crossing or two crossings, so a temporary bridge to allow a 500-ton crane to mobilize and get onto site and then leave again. That's just two crossings. That solution of crossing will look very different if it's only got to be used twice, as opposed to something that's going to be used for the next 2 years and with like 20 odd passes a day of bulking lorries, etc. Those are going to look very different. So timings of the removal is something that's quite influential on the design of how heavy something's going to be, I'd say. Okay. Now let's look at why a good design brief is important. It's important so we can design something that solves the overall problem. We can use accurate information to complete the designs, making them safer. It avoids revisions and makes design process quicker. The correct approvals are therefore going to be in place, so it enables mobilization on site a lot quicker. And it avoids rework on site as well if the temporary works and installation removal sequence hasn't been thought about in the first instance. And I'm going to bring up my old soapbox and stand on top of it and talk about GIGO, because it's garbage in and garbage out. If what we're putting into the design brief is a load of rubbish, then the design that's going to come out at the back end is also going to be a load of rubbish. The more accurate that we have, the more accurate information that we have at the beginning, and the better the design brief we have to design, then the design engineer who's carrying out the work is going to know exactly what to do and exactly what to allow for, and is going to give you something that is going to work a dream on site. Okay, so that's GIGO, garbage in, garbage out. And that's worth remembering and keeping in mind when we're writing these design briefs. On to our first case study then. So this is more of a generic case study, I'd say, looking at a mobile crane position that we have on a site, something quite regular that comes through. So here we've got a straight from our template, the undone design brief template. And you can see that we've got some items in here, project title and name and task number, etc. So these will just be accordance with whatever you've got in your temporary works register. On the right hand side, you can see we've got the category design check, which is just a tick box. Here we've gone with Cat 2. Implementation risk as well. We've got very low or low on the left-hand side, medium, which is ticked in this case, and then high. Task numbers, due date, start on site. On these, from my recommendation, anywhere where you're putting a date, so we've got the due date there and date of preliminary sketches, designs, etc. It's very tempting to put as soon as possible, ASAP. But you got to remember, ASAP means a lot of different things to a lot of different people. If you put a particular date in there, even if it is that day or the next day, then when that design brief floats through, hopefully you've given them a call beforehand, but once that design brief comes through, and somebody sees that date, which is tomorrow, you're more than likely going to get a phone call thinking, whoa, hey, I see that this is due for tomorrow. We're really going to struggle with that. Let's talk what we can do for you. As opposed to if something comes in as soon as possible, it may be going to a design engineer, sipping his Starbucks coffee, thinking, oh, ASAP, as soon as possible. Maybe sometime next week. That's when we can do it, which I know for a fact on the site team, that's going to think, well, as soon as possible is this afternoon if possible. So always put a date is my recommendation. We've got the design, who's written it. So this case is David Stevens, signed and dated, and the contact details if you need to get in contact. And then at the bottom here is a description of the temporary works. So here we've said we're looking to use a crane to remove sections of the advertising tower. The crane is to be positioned to the rear of the structure as shown on the attached plan. And we'd like a design for an outrigger position to allow for the crane to operate within the service yard and check the services beneath the service yard too. In this case, the site is fictional. Okay, so it's just a general overview of the temporary works that we've got on there. The next page, we've got preferred methods, systems, and types of equipment. So the preferred solution is we've got some timber mats which we can use. So we'd like you to spec them, please. Ground conditions and groundwater level, soil types. So you can see there that what Dave's put into this is we've got an attached site investigation report. Borehole 7 is the closest borehole, and we've highlighted that on this drawing. Construction drawings, the service yard show that the ground makeup is this, that's put in there as well. Okay, so it's a succinct review of these. This is the information that we've got, and these are where to find them, essentially. Design limitations, site imposed. So the crane is not adjacent to any network rail assets, and works are to be undertaken as a contract lift. We've got the loading requirements. So that's a screenshot from the crane supplier, who has identified what the outrigger load is, and then Dave has put maximum outrigger load is 140 odd tons, as shown on the attached crane plan drawing. So he's going to be attaching that as well. This design brief is going to be going hand in hand with I suppose a file of supporting information, of which that crane plan is one of them. Access limitations, just not applicable in this case. And then we've got existing services. So he's put a plan there of the services locations, because that's important to review as part of this design, because we need to be carrying out a service capacity check. Previous works in the area have shown the depth of the makeup to be accurate. So he's put a nice picture in there of what the ground profile looks like. Other information, not applicable. Additional information, we've got crane position, as-built information, site investigation report, service drawings, photos, etc. These are going to be brought in as well once this is packaged up and sent through to the design engineer. And that is all you need. That's pretty detailed. That is a really good example, but it doesn't need to be that detailed. It just needs to have the succinct information that you're trying to communicate across to the design engineer. But the more detailed it is, the better the output of the design solution is going to be. And as well, the more detailed it is, if you're getting a lump sum quote from a design engineer, the more detailed it is, then the less unknowns and the less unknown risk that the is going to come back in the price of the quote that you're getting back. If there's a lot of kind of woolly statements of, well, there might be services, so you might need to check that, or I'm not sure, then the quote's going to come back with either an exclusion to check services, which you might need, or it's going to come back with an allowance to check services, which you might not need. Okay. On to the next case study then. So this is the Old Granada Studios in Manchester for Bowman Kirkland. And I'm going to take us through the project, I suppose, and a particular part where we're going to put a design brief. So if we just jump back one. So it's Old Granada Studios. You can see that's the structure there. And it was a there was a structure there initially. It was demolished, and then a new basement redevelopment scheme, which you can see on this photo here on the right-hand side. That is basement pile caps constructed, and the basement floor in, and then the first floor level formwork you can see in the background there. So we're bringing up, so not first floor, ground floor, and then working across to the elevation where the photo is taken. So you can see we've got props to the perimeter wall to support that perimeter wall and prevent the road from coming into the site. On the left-hand side of that photo, we've got an adjacent building, and then on the far end, we've got another adjacent building there as well. And you can see that in the schematic. The proposal, we've got a tower crane, and then we've got a core coming up, and then we've got some steelwork there as well. So the design brief of what we were trying to do. So we had this first ground floor hadn't been constructed yet, okay? And we had to accommodate quite a large MEWP to operate on this ground floor to assist in the steelwork construction, which you can see on the photo on the right-hand side at the bottom. So we had a large MEWP operating on the ground floor of a structure that had design loadings for just pedestrian access, and we wanted to see if what MEWP size, or if the MEWP size that our subby could use would work on the structure. So let's have a look at our template here. In this case, we had so we got the project name, the task name, etc. The design check category in this case was Cat 1 or Cat 2, because we tick those thinking, well, we're not sure whether it's going to be one or the other, and then that can be refined as the design process goes through. Sometimes you might find that it's actually quite simple, and so it doesn't really warrant something like a Cat 2 check. In other cases, you think, well, yeah, that should be quite simple, and then as you start working through the designs, wow, this thing is growing arms and legs and turning into the right beastie, so I think it warrants a Cat 2. So it's really on receipt of that initial design is when that checking requirement is confirmed. Implementation risk is medium on this particular one. Due dates, we put a few there. So we'd like a concept, and then we'd like a working design, and then start on site, some dates there, and then they are filled in through also the scope of the design required. Description of temporary works required, including references. So we've got 15-ton MEWP required to operate on the ground floor slab to facilitate the installation of steel from levels 1 to 6. Structure details attached down the ground floor has not been constructed yet. The MEWP will need to operate over the whole slab over the course of several weeks. So we've got some timeline there. We've got what the current start of the site is there. We could add some photos in as well, just to kind of show this is the description of where we are and what we need. Preferred methods. Structural engineers have stated that the proposed MEWP point load from the wheel is too great. Therefore, simple backpropping to the ground floor basement with acro props or similar would be suitable. We have easy access to acro props on site. So they've got loads of them, so they'd like to use those if need be. Ground conditions, we've got a basement slab as per the drawings attached, and the pile design and site investigation report is also attached. You can just put that to the back and send that through as the package. Design limitations, the MEWP will need to access all areas of the ground floor slab, so it needs to go everywhere. That's very important, because if it only needed to go in a particular location, then that really reduces the scope of the temporary works design. If you just sent it through, we'd like the MEWP to work on the ground floor, and then there may well be a very complicated part of the structure which really doesn't need to be looked at from the temporary works engineer, because the MEWP's not going to go there. But if that's not specified in the brief, then that's not that's going to be included and end up taking more time and increasing cost. So we've got design limitations, particular loading conditions as well. So the MEWP has operational weight of 15 tons, see spec sheet attached. It's going to be operating on a live construction floor. Therefore, the design must consider construction loadings on the same slab as the MEWP if possible. Access limitations. The ground floor slab has no access limitations. The basement is accessed via hoist and new stair core. There are no services in the area. And other information, we've got see attached sketch from the steel director. So that may well be the subby who said, yeah, I'm going to be sitting my MEWP here. There's also going to be another MEWP next to it, or a smaller scissor lift that can then inform the loadings assessment on the design. And there's no third-party approvals that are necessary. Additional information see these drawings. Okay, so that's a fairly well-written brief, I'd say. So the assessment of the temporary loadings from that design on the structure resulting from the construction plants, such as the MUPs and the cherry pickers, the pallet trucks, etc., that proved quite interesting, actually. So the structure wasn't designed for these heavy loads. It was just designed for an area loading. Therefore, in this scenario, we asked for the permanent works designer to look at the backpropping. So the first instance, it was, hello, Mr. Permanent Works Engineer, who's designed this lovely slab. Will the forces work on that slab? Well, no, the point loads are too high for that, I'm afraid. So you'll have to seek assistance from Temporary Works Engineer. Okay, so let's look at, if that fails, then we can put some backpropping in, surely. But hold on a second. Surely there's a better solution to some backpropping, potentially. So the key to this is that the contractor had planned ahead of time, and so that the slab hadn't been constructed yet. So in this real life situation, we reviewed the loadings from the various plant and checked the new slab design for bending, shear and deflection without any backpropping whatsoever, just to see how far it failed or where it failed. If it's in a particular place, then we could just put props there, for instance. But we checked the punching shear in the column heads and the column capacity, as well as all the loading in the piles. So we did a full-on review of that structure from the plant loadings that we're putting on there. And we concluded that backpropping could be omitted if we introduce some additional reinforcement. So if we strengthen that slab slightly, and that was in the form of some A393 mesh in certain areas. The failure areas, I think, on this model were the purple, that purple zone, and then the greeny kind of zones above the column heads. That's where we needed to strengthen the structure. So following this conclusion, we produced this drawing, which demonstrated that proposal. This solution removed the requirement for any backpropping and its associated costs of installation, hire, and removal. And in addition to that, which was quite key really for the contractor, was that it enabled the basement finishing works that they could proceed because there were no props in the way, which was on their critical path otherwise, which is a fantastic result. So the solution was very effective in speeding up the program, reducing the costs, whilst also maintaining the required margin of safety. But it did require some forward planning, which is really important. If you think ahead, you get ahead of the game. But this links back to something that makes a good design brief, is an idea of what is expected without kind of leading the witness or leading the designer. It's not saying, well, we'd like this, please. It's producing the problem, kind of setting out the problem that needs to be solved on site, so you can use your design engineer's experience to find the best solution for you. So hopefully those two case studies have reinforced what can be achieved with writing a good design brief. Planning early definitely pays dividends. So it's just a kind of a wrap-up summary before we go to some questions. Providing succinct, accurate information in good time, not saying, well, this is the information, it's all on the project database, here's the attached link, all the drawings are there. It's finding that information and providing that succinct and accurate information, highlighting risks to increase safety really. Any materials available or preferred materials is to better inform the designer on what tools they have easily available on site to keep costs down and keep program sharp. An idea of what is expected without leading the designer, as I've discussed. The timescale and making them realistic, not put in ASAP, as this means different things to different people. And then design live, like I mentioned earlier. So you'd be surprised at what an engineer can do with the knowledge that something's going to be used once as opposed to repeatedly over the course of 6, 12, 24 months. Knowing that design life leads to lean and quite efficient design. But ultimately, a design brief is so that we can understand the problem and therefore get to the most efficient, safest, and cost-effective solution quicker. Okay, so that brings us sadly to the end of our presentation today, but hold on to your horses, because that's not all that's on the subject. There's loads of stuff out there. This presentation is certainly not everything you need to know about design briefs and temporary works. There is plenty of information out there, and I've listed a few here. So the Temporary Works forum produce a lot of good stuff. There's a guidance on the constructability of Temporary Works, as well as a lot of content on their website, worth a look. BS 5975 itself, which is the go-to code for Temporary Works design and procedural control of Temporary Works. There's a Safe by Design focus group, early focus on, which is spearheaded by Steve Williams and his team at Network Rail. There's a very good document which is called Guidance Note on the Early Focus of Constructability and Temporary Works. So that's worth a read as well. And then finally, there's the Yandom webinars. How could I forget? 90 plus videos on there with all sorts of content ranging from complex demolition case studies to net zero challenges to crash course in plate bearing tests on working platforms, just to name a few.